For millennia we gazed at the stars, our ancestors mapping constellations and seeking meaning in the night sky. The heavens inspired myths, guided explorers, and sparked questions about our origins and our place in the cosmos. We searched for our place in the universe, wondering if we were alone and what mysteries the vast expanse above might hold. Our curiosity drove us to build telescopes, launch probes, and reach for the unknown. But our most profound discovery came when we looked back at Earth, a fragile blue marble suspended in darkness, breathtaking in its beauty and vulnerability. From space, our home appears both isolated and precious, a singular oasis in the void. This cosmic perspective changed everything, revealing our planet as a single, interconnected system. Borders vanish, and the thin atmosphere that shields us becomes strikingly apparent. From space we see swirling weather patterns, the glow of city lights, and the pulse of civilization. We witness the rhythms of nature and humanity, intertwined and inseparable. Satellites give us the high ground, letting us monitor Earth's health in ways impossible from the surface. We measure polar ice, ocean temperatures, track deforestation, and observe the shifting patterns of life across continents. We analyze the air we breathe, monitor greenhouse gases, and gather vital data for survival in the 21st century. These insights help us understand the delicate balance that sustains life. These orbital sentinels are our planetary guardians, providing early warnings of storms, droughts, and other threats. They tell the ongoing story of our world, day after day, year after year. The data they collect is the key to understanding climate change, managing resources, and responding to disasters. With this knowledge, we can make informed decisions to protect our future. Without these eyes in the sky, we'd be flying blind in a rapidly changing world, unable to see the warning signs or respond to global challenges in time. Our ability to look back at Earth is one of the greatest gifts of the space age, a reminder of our shared responsibility to care for this planet we all call home. To ignore or blind these sentinels is to turn our back on our own well-being and to lose sight of the fragile beauty and unity that space has revealed to us. Among our most critical sentinels are NASA's OCO2 and OCO3 missions, Earth's atmospheric doctors. Their job measure carbon dioxide in our atmosphere with unprecedented precision, down to the scale of a city or power plant. By analyzing sunlight filtered through the air, they map CO2 hundreds of thousands of times a day, revealing where it's coming from and where it's going. This data is essential for understanding the planet's carbon cycle and holding ourselves accountable. OCO satellites show us the planet breathing, forests inhaling carbon in summer, exhaling in winter. They can spot the carbon signature of a city and verify if emission reduction efforts are working. The data is an independent, unbiased record, a fact-checker for climate policies worldwide. When countries claim to cut emissions, OCO can help verify those claims with direct observation. These satellites are our truth-tellers, guiding climate action for future generations. The OCO missions were originally designed to track carbon dioxide in Earth's atmosphere, helping us understand the global carbon cycle. But in the process, they delivered a revolutionary bonus, detecting solar-induced fluorescence, or SIF. This is the faint, invisible glow emitted by plants during photosynthesis, a subtle signal that reveals the hidden activity of life on our planet. SIF acts as the real-time pulse of the planet's biosphere, showing us exactly how actively plants are photosynthesizing at any given moment. It's like listening to the heartbeat of Earth's living systems, capturing the rhythm of growth and change across continents and seasons. Unlike older methods that only measure greenness from space, SIF reveals the actual metabolism of plants, even when they appear healthy on the surface but are silently struggling with stress. This means we can detect problems before they become visible to the naked eye. This breakthrough allows scientists to assess crop health and spot the earliest signs of drought or stress, sometimes weeks before they escalate into full-blown crises. Early detection is crucial for taking action and minimizing losses. With this information, farmers, governments, and aid organizations gain a critical head start. They can manage food supplies more effectively, respond to threats, and help prevent famine in vulnerable regions. OCO satellites have become global agricultural monitors and drought early warning systems, providing a constant stream of data that supports decision-making on a planetary scale. Agencies and organizations worldwide now rely on this data for forecasts that affect food markets, humanitarian aid, and even international policy. Listening to the whisper of plants gives us an unprecedented tool for food security, helping us adapt to a changing climate and protect the world's harvests. It's a powerful example of how fundamental science, driven by curiosity, can yield practical benefits that touch millions of lives. The OCO missions are more than just carbon trackers. They've become guardians of our food supply, quietly watching over the health of our planet. Investing in exploration and technology has strengthened the very foundations of our society, connecting science with everyday life in ways we never imagined. The faint glow from space, once invisible, now helps us protect life on Earth, reminding us that even the quietest signals can have the greatest impact. A single measurement is a snapshot. A decade of data is a story. Since 2014, OCO2, and since 2019, OCO3, have provided an unbroken thread of high-precision data about Earth's carbon cycle. This long-term record is exponentially more valuable than scattered snapshots, revealing trends and fundamental changes. It's like a patient's medical chart, showing how our planet responds to climate events and human activity. The OCO program's data is public, fueling thousands of scientific breakthroughs and global collaboration. It's become a shared language for climate science, connecting researchers worldwide. Breaking this data stream would be like tearing pages from the world's most important history book. The decade of observation refines our climate models, making predictions more accurate and reliable. Without this continuous record, our ability to forecast and plan for the future is severely diminished. The OCO missions are the bedrock of our understanding. Their loss would leave us in the dark. As of September 2025, these vital missions face termination. The satellites that have quietly orbited above us, gathering crucial information about our planet's health, are now at risk of being switched off for good. Shutting them down means destroying perfectly functional, multi-million-dollar instruments providing irreplaceable data. These are not just machines. They are the eyes and ears of our planet, built over years of innovation and international collaboration. The immediate consequence: an enormous gap in our knowledge and the abrupt end of a decade-long climate record. Scientists and policymakers would suddenly be left without the tools they rely on to understand and respond to our changing world. It could be years before a comparable mission launches, leaving a blind spot as Earth continues to change. In that time, critical trends could go unnoticed, and opportunities to act could be lost forever. Losing these satellites means ceding American leadership in space-based carbon monitoring to Europe and China. Other nations would step in to fill the void, setting the pace for global climate science and policy. We'd go from global data provider to consumer, retreating from a position of scientific strength. Our researchers would depend on others for information, limiting our ability to lead and innovate. The risks go beyond data and prestige. We'd lose unique drought and crop yield forecasting, threatening food security and economic stability. Farmers, emergency planners, and entire communities would be left with less warning and fewer resources to prepare. In a world already stressed by climate change, blinding ourselves to early warning signs is profoundly irresponsible. The loss of these satellites would make it harder to predict and respond to disasters, putting more lives and livelihoods at risk. OCO insights help prevent food shortages, market volatility, and humanitarian crises. Their data supports relief efforts and helps stabilize vulnerable regions before emergencies spiral out of control. The price of silencing these satellites could be paid in lost lives and global security. The consequences would ripple across borders, affecting millions. This is not just about science, it's about our future. The decisions we make now will shape the world our children inherit. The loss would be felt worldwide, undermining decades of progress in understanding and protecting our planet. We cannot afford to turn away. The stakes are too high and the time to act is now. The argument for shutting down these satellites is baffling when you consider their value. The $750 million investment is already made. The satellites are built, in orbit, and working perfectly. Annual operating costs are just $15 million, a rounding error in NASA's budget. For this tiny sum, we get a real-time health check on the entire planet. The return on investment is colossal. Data that protects food supplies, informs economic decisions, and guides climate action. Decommissioning these missions isn't about technical failure, they're in excellent health and producing exceptional data. Scientists are aghast. The decision is ideological, not scientific or economic. It's like demolishing a state-of-the-art hospital to save on the electricity bill. The logic doesn't hold up. For the cost of a few miles of highway, we get global security and knowledge. Throwing it away is reckless and wasteful. The value proposition is overwhelmingly clear. The story isn't over. There's a powerful push to save the OCO missions. Scientists, the public, and Congress are speaking out, challenging the shutdown. A bipartisan group in Congress has demanded NASA keep the missions running, and the Senate's draft budget rejects the terminations. The fight is now in the budget process, weighing science against cuts. NASA has even explored privatization, raising questions about the future of public science. The coming weeks will decide whether we keep our eyes open or blind ourselves. We stand at a crossroads, a real, urgent decision with profound consequences. One path is continued observation, knowledge, and vigilance guided by data from satellites like OCO2 and OCO3. The other is willful ignorance, shutting our eyes to the planet's health and dismantling our tools for survival. This decision is about more than satellites. It's a test of our character as a civilization. Do we value the long-term health of our planet over trivial savings? The universe is vast, and this blue world is our only home. Monitoring Earth's health from space is one of our most precious capabilities. To dismantle it would be an act of cosmic folly. The choice is simple and urgent. We must keep our eyes on Earth. Our survival depends on it.